inertia. So now let us move on to a new part, a next so-called concept in this topic, mass with density, which is density. I believe this term will be quite, you all should be quite familiar with this term already. Sorry. Okay. Okay, I'll be going through all this very fast because you have learned it before. So the definition of density is basically just mass over volume. Okay, and this is the formula, mass divided by volume. Then the SI unit for density is kg per meter cube. Because the SI unit for mass is kg, the SI unit for volume is meter cube. So mass divided by volume is kg per meter cube. Some other common units for density will be gram per cm cube and also kg per liter. Okay, as long as it's mass divided by volume, it is a unit for density. Okay, and some usefulness for density. Why do we want to learn density? Basically, density can actually tells us whether an object will float or sink in a fluid, in water, and also it is useful for scientists and researchers because they use density to actually identify materials. Because every material got a fixed density. Okay. Now let us move on. Okay. So to find the density of a substance, other than knowing the formula for the density, mass over volume, it is not enough. The first step to find the density of a substance, you have to measure the mass first. You have to obtain the mass of the substance, okay, and then you determine the volume. And once you determine the volume, you can then use the formula mass divided by volume to get the density. Okay. Now finding density of substance. So I have a question for you guys. Describe how you can determine the density of a regularly shaped solid. Example, a wooden block. So just now I mentioned the 3 steps, correct? First you find the mass, then you find the volume, and then you divide the mass over the volume to get the density. Okay? Maybe Kenneth, describe how can you determine the density of this wooden block?
So maybe I put the wooden block on a weighing machine to find the mass.
Okay, weighing machine to find the mass.
Then maybe I try to calculate the volume of the wooden block.
How do you calculate the volume?
Base area times height.
Base area times height. Okay, good. Using mathematical formula.
Yeah.
And then,
And
lastly,
calculate density using mass over volume.
okay, good. Now, this is easy for a regularly shaped object. But what about an irregularly shaped solid? For example, this piece of rock over here. Timothy, give it a try.
Smash it into powdery form and then measure. I don't know.
Okay, first you want to find the mass first, correct?
Yeah.
Remember the 3 steps. Measure the mass first, measure the volume, and then divide mass over volume.
Correct.
So the first step, measure the mass. How are you going to measure the mass for this?
Putting on the weighing balance.
Okay, good. So you get the mass ready.
Yeah.
What about the volume?
I don't know. Yeah, I don't know. I'll measure the width, breadth, and height. I don't know.
Chandra,
Displacement method.
displacement method. Can you elaborate?
Just put the stone into a water, see how much volume of water has been displaced.
Okay, good. Then that's the method to determine the volume. Okay, how much water is displaced is actually equals to the volume of the solid. So once you get the volume, same thing, you use the formula mass divided by volume. Then you can get the density. Okay, thank you, Chandra. Now, what about liquid? Jimmy? How do I determine density of a liquid?
Yeah, to get the volume, you can pour the liquid in a measuring cylinder and then you weigh it off.
Okay, can. Yes, good. What about the mass?
The mass, you transfer the liquid into some other container first. You find the mass of the glass by using a weighing scale. Then you pour back the liquid and then you find the total mass.
Yes, and then you subtract
Yeah.
to get the mass of the liquid. Okay, good. And then again after that you apply the formula mass over volume to find the density. Okay? Now we all know how to find the volume, we all know how to find the density of a substance. Let us move on to the next part, the floating or sinking of objects. I believe this one should be quite familiar for you guys. Okay? If density of object is greater than the density of the liquid it is in, what will happen to the object? Kenneth?
It will sink.
It will sink. Okay, good. Then if the density of the object is lesser than the density of the liquid it is in, what will happen? Okay.
You float.
Okay, good. What if the density of object is equal to the density of the liquid? What will happen? Okay. Good try, Timothy. Blind.
I think it will suspend in the water. It will not float and it will not flow, but it will also not sink to the bottom of the.
Okay. You say it will suspend in water.
Yeah.
Jimmy, what do you think?
I think so, but I haven't seen it before.
Okay. I will show you what will happen if the density of the object is equal to the density of the liquid. So the density of the liquid here is water. Okay, based on this simulation here, this is water. Okay, the density of the water is 1 kg per liter, and this is my so-called wooden block. Not wooden block, a block. Okay, and the density of it is 1. How do I know it's 1?
5 divided by 5.
Okay, good. 5 divided by 5, so it's 1. So let's see what will happen. Okay. Can you see what happened?
It floats,
It floats, right?
Why?
Right? So basically, the cube has the same density as water. Can I actually say that this cube is something like a water inside this water? So it can actually move really inside this water, right? If you to move it. Okay. So this is what will happen if they have the same density. Now, how do you explain this? How come the cube now sinks?
Because you threw it.
Yes, Jimmy.
I don't know, because you threw it.
Yes, good. Okay. Because I bring it to a certain height. So it has some energy before it drops. Okay, there's some potential energy. This one you all will learn later. Okay? Okay, so back to the floating or sinking.
Explanation very good.
Now, other than the density of an object that determines the floating or sinking of the object, what if? How do you explain this phenomenon? Because density, aluminium, you know aluminium, correct? Aluminium has a density higher than water. Aluminium has a density of 2.7 kg per liter, and water has a density of 1 kg per liter. Now, in reality, a ship hull is made of aluminium. It's usually made of aluminium. Okay? And ship can float, right?
Yes.
Yes. How do you explain this? Aluminium is denser than water, right?
The composite density.
Composite density.
Maybe the air inside the ship hull need to take into account as well.
Okay, good try. Okay. How the ship is actually able to float water is because of this buoyancy. Okay. The ship the ship hull is shaped in such a way that it can displace the amount of water, and it can displace an amount of water that is equal to the weight of the ship. Do you all get what I mean?
No.
No. Okay, good. Never mind. I'll illustrate this with the simulation just now. Okay. Just now I have this block, right? Let's talk about the roof first. Now you all learn in forces that every object will have weight, right? And this weight is because of that the gravity. So from here we can see that the weight of this wooden block is 19.6 Newton, right? Because the gravitational field strength is 9.8 in the case of this simulation. So 2 times 9.8 is 19.6 Newton. So this is the weight. And based on Newton's third law, you know that there will be an equal action and reaction force. So when you drop the object into the water, okay, because of the weight of the object, it actually pushes the water downwards. Okay, and then because of this, the water will actually so-called exert another equal force upwards, and we call this the buoyant force, which is why the object can float in the water. Yes.
Why will it bounce? Like you drop, then initially it will like bounce, right?
This one is because of energy. Because you drop it at a certain height. Right?
So if you drop higher, it will bounce more. Okay, higher a bit.
Later I'll show you how you continue after that. Okay, so this is the concept of buoyant force, okay, which causes an object to float. So back to this this floating of the ship. So aluminium by itself, if it is in a cube form, okay, if you were to drop it into the water, it will definitely sink because it is denser than water. But if you are able to shape the aluminium, the same block of aluminium, in such a way that it can actually displace more water than the previous shape in a cube form, you can actually so-called float it, okay, in the water. Understand?
Understand?
Okay. So this is how it actually works. So you have the gravity that is pushing the ship down, okay, into the water, and then the ship displaces a certain amount of water that is equal to its weight, and because of this is the buoyancy, the buoyant force that pushes it up. That's why it floats. Okay, and as you add more load on the ship will sink further. It will displace even more water to support the increase in the weight of the ship, the total weight of the ship. Okay, and if you were to increase it furthermore until it actually cannot so-called withstand the load, the ship will sink. Okay, understand this concept?
Understand?
Okay, yes. So to summarize, the concept of density of floating and sinking, an object will float as long as the density is lower than the fluid that it is inside it. Okay, if it is heavier, the density is higher. It doesn't mean that the object will sink. Okay, but if you are able to shape the object in such a way that it can displace the amount of fluid that's equal to its weight, you will be able to float in water. Okay, so that's all for my presentation.